Okay, good afternoon, class. Alright, so you guys got your scripts back. This is the grade 11 cycle test 2 of 2024 of our school. This is what I expected you to have written to get a nice mark. Okay. The question paper and memo can be found in the description box below. People, the first one was a given. I told you this is coming in. Most of you got that right. Otherwise, the link to this proof can be found in the description box below. Okay. Number 1.2. This is where the nonsense starts. Okay. So here, let's pull this over. So here we are told that PC, the diagram is a bit big here. Okay, we'll enlarge it now again. Okay. So we are told that PC and PA are tangents to the circle at C and A respectively, which means to say in that order. Then we are told if both of these are tangents, then that angle is equal to that angle. Why? And tangent from common point, and then angles opposite equal sides. Right. Then we are told that CB is produced to meet AP. So CB is produced to meet AP at F. AB and AC and DC are drawn. So from this information, that in blue is what we need to retain. Otherwise, everything else is on the diagram. Okay, so I'm going to enlarge this now. So you can see what's happening here. Okay, so that's your diagram. First question, prove that. So the question says, prove that AC bisect. So AC bisect PAD. So if CA is bisecting this angle, then that angle we need to prove is equal to that angle. Now some of you started with B2 being X. For what? For what? You must start with one of these being X, people. Here. So what do I say? I say let A2 equal X. Right. Which other angle is equal to X? Of course it won't go straight into A2 and 3 and 4. So we see this is alternate angles here. So C1 and 2 is equal to X. C1 and 2 is equal to X. Why? Alternate angles. Alternate angles with AD being parallel to PC. So there's an X line here as well. Or you can call it PCA. Then I told you that this angle is also X, which is A3 and 4. The sum of those is also equal to X. Why? Tangent from common point. That's number 1. Okay? As well as angles opposite equal sides. You must write both because there's 2 theorems we are using there. Okay. So what do we notice now? They are equal. So now we state the obvious. Since A2 is equal to A3 and 4, which is equal to X, therefore CA bisect PAD. Therefore it's cutting it in half. Okay. So that is also marked the same thing. So everything we have here is on the diagram. Let's take it off. Let's go to the next question. The next question says, prove that B1 is equal to B3. Now we say, okay, B1. You see as B1 here. But B1 is also X. Can you see that? Angles in the same segment. So I'm not going to introduce a Y here. Okay? I'll go with X. So I say, is the different color here. So we can say that B1 is equal to X. Why? Angles in the same segment. Can you see that, people? Equal to X. Angles in same segment, and it's coming from arc CD. Okay. So now I must still prove that B3 is X. So you see here, B3 is also equal to B3 is also equal to D1 and 2. Why? Exterior angle of cyclic quad equals the interior opposite. So if I can prove that D1 and 2 is X, I've done the job. I say, hang on. This is an exterior angle. This is a tangent here, not so. So is it not that C1 and 2 is equal to D1 and 2? Why? Tan co-theorem. So let's go with that story. So D1 and 2 is equal to X. Tan co-theorem. Here's an X. B3 is also X. Why? Exterior angle of cyclic quad equals the interior opposite. There we go. Therefore, B1 has to be equal to B3, which is equal to X. Yo, I couldn't have made it easier for you. No, I tried. I've tried, people. Okay. Let's go with the third one, the third question. This had to be like 12 marks giveaway. That's why I made it question 1. To make question 1 easy marking. But you got hey. I thought it was, after marking the first 3 people, I thought it was a prank. See, you guys are like, take me for a joke or something. Right, APC. Let's go. APC. APC. How's it? Which is the combination of P1 and 2. So how do we calculate this? Sum of triangles. Most of your diagrams were spotless. Which means to say you guys didn't write on your diagram sheet. That is why we give you 2 copies of a diagram. One in the question paper and one in your answer book. Do we give it to you to leave it crystal clear? No, people, man. So that angle. So we say APC is equal to 180 minus 2x. Or we say x plus APC is equal to 180, sum of triangles. And this is triangle PAC. So if I can prove that ABD is also 180 minus 2x, I've done the job. So let's see, where's ABD? ABD. This one here. So hang on. What is that? Straight. You are all giving me the answers, I imagine. So ABD is 180 minus 2x. Why? Straight line. So what else do we have to say? Therefore, APC is equal to ABD, which is equal to 180 minus 2x. Bob is your uncle? 12 marks in the bag. Easy, people. Like I tell you before, it's easy to see somebody else do it. No? Don't tell yourself, I'm going to figure it out in the exam. Not for maths, okay? I don't know for what subject you can do that for. Don't also give the subject, please. Alright, here we go. Another giveaway. Okay, most of you got this marks in here. Alright. So in the diagram alongside, P which is negative 4 and negative 3 and negative 4. I conclude the triangle, that's an x and a y, so that's negative 3, that is negative 4. Is a point in the Cartesian plane, and the reflex, which is this outer angle here, is going to be your theta. Right. Without using a calculator, find cos of theta. So cos is, remember that's my reference angle. What does cos stand for? Adjacent of hypotenuse. In other words, I need OP. Not so. So OP is your hypotenuse. So OP squared is equal to negative 3 squared plus negative 4 squared. I'm using the Pythagorean theorem, so OP works out to be 5 there. Remember, that can't be negative. So cos of that theta angle, cos is adjacent, which is negative 3 over hypotenuse, which is 5. Easy. Now we go for number 2. Number 2 says sine of 180 minus theta. Which quadrant is 180 minus theta? All stations to Claremont. 180 minus takes you to the second quadrant. Is sine positive or negative in the second quadrant? Positive. So it's positive sine theta. But what is sine of theta? Sine is opposite over hypotenuse. So it's negative 4 over 1. Let's look at number 3. Number 3, we have tan of a negative angle. So what do we do here? Add 360. So it's, in other words, it's tan of 360 minus theta. Which quadrant is 360 minus theta? The fourth quadrant. Is tan positive or negative? Negative tan theta. So it's negative. What does tan stand for? Opposite over adjacent. Opposite over adjacent, eh? So it's negative 4 over negative 3. Negative, 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 negative 4 over 3. That is how you do it. Yeah? But as I said, I think some of you lost the 1 mark here. You wrote this here, and then you wrote positive here. I think some lost that mark here. So just watch out for that. That wasn't my concern. This one was also answered. Most of you got 4 out of 7 here. Let me show you how to get 7 out of 7. Okay. So we go. All stations to Claremont. Some of you in your whole paper or in your question paper don't see the story. Okay. So we go. People, this is over 360. So what do we do? Subtract 360. So 720 minus 360? 360. 360 plus theta is in your first quadrant. Sine is positive. So it's sine x times 90 minus which quadrant? 90 minus first quadrant. Sine positive or negative? What changes to? Cos x. What does it change? Co-function. 180 plus x, which quadrant is that? Third quadrant. Is cos positive or negative? Negative cos x. Over. Now the 135 is in which quadrant? Second quadrant. How do we get in the second quadrant? Tan 180 minus 45. Now you see, what does this mean here? Can't use a calculator. Now some of you type in a calculator tan of 135, you get negative 1, and then you can't get the simplifying answer, and you can't get the reduction answer. You already lose 2 marks. This is what I want to see. Okay? Minus 360 minus, which quadrant is that in? Third quadrant. Sine positive or negative? Negative. But because of that negative, it becomes positive. Now some of you see the negative, you know it's negative and you leave it negative. No. That negative is because of the sum. And the other negative is coming from the reduction here. So it's sine of x. So as you can see on top, nothing can happen. Some of you might cancel the signs here. Go on. Take out the common factor of cos x. So I'm left with sine x minus 1 over. Tan of 180 minus. Which quadrant is this in? 180 minus second quadrant. Is tan positive or negative? Negative tan of x. Now 45, sorry. Plus sine x. Now 45 takes you where? Special triangle. That is your isosceles triangle there. What is tan of 45? 1 over 1. So it's cos x into sine x minus 1 over negative 1 plus sine x. So hang on. Sin x minus 1 cancel, minus 1 plus sin x. The answer is cos x. People, this is how we mark this thing. That's why it's so many marks. 7. There's 1, 2, 3, for the 10. There's 4. I think you get 5 there. 6, 7. Okay. The question paper can be found, the question paper and memo can be found in the description box below. Yes, Michael? Oh, you're counting with your fingers in the air. Nice. Let's go to the next one. 2.2.2. Sine of 30 times sine of 230 over cos of 140. So sine of 30 takes you to the special triangle. 30. 1 to root 3. Sine of 30 is half times. 230, which quadrant is 230 in? All stations. Euclidean one. Which quadrant, people? 3. How do you get the third quadrant? 180 plus 50. So now, you see, this is not a special angle. So I'm going to link that to that. So it becomes cos of what? How are you going to get 50 here? 90 minus 90 plus 50 is. So that can cancel somehow. So it will be half times 180 plus. Isn't that quadrant not so? Sign positive or negative? Negative, but it remains sign of 50 over 90 plus. Which quadrant? Second quadrant. Is cos positive or negative? Negative. Although it changes to sign of 50. So what happens? Cancel. Including the negative. The answer is half. Now some of you got the half and got nothing out of 4. Or 1 out of 4. Because you catch the nonsense, no? You don't have your signs here correctly. Both has to be negative. Okay. Because listen, if I put this in a calculator, I get the half out. So you fidget, whatever you guys do, and you get the half. When you come out of the exam, the paper, yes, this one is in the bag. Makanti. No, you guys are doing your own nonsense. Alright, let's go to the next one. Prove the following identity. So what we do here, left and right hand side story. So left hand side is more complex. So tan can change to sine over cos. So it's sine alpha or sine A times sine A over cos A. People, what's your LCM here? Cos A. This was an easy one, eh? So that term was multiplied by cos A. Cos A. So you're going to become cos squared A plus sine A times sine A. Sine squared A. So what is cos squared A plus sine squared A? 1 over cos A. Which is equal to the right hand side. Very easy, no? Many of you got that one, right? But now, when it came to the easy part, I couldn't understand. People, the question says solve for x. What type of sum is this? Inequality. This exercise 2.16 years. We did this not too long ago. Take it over the equal sign. So I get 8x squared minus 2x. I factorize this. 2x is a common factor. I'm left with 4x minus 1. Now some of you go and you're right. 2x is greater than 0 at... No. Must get what we call critical values. What gives you 0 here? 0 and a quarter. Take it to the graph. You get 0 and a quarter. What does this tell us? The function must be greater than 0 is, which means to say it must be positive. So it's above here, above the line. So what do we say? X must be less than 0 or it must be more than a quarter. X must be less than 0 or X must be more than a quarter. This is how we mark it, no? We get 1 here. 1 there, critical values. You must have critical values here. Okay, you can't say x equals 0, x equal to a quarter. If you say that, you lose everything out after that. Now, this must be right for you to get your further marks. If this is wrong, you are screwed. Right. Now, I check on your diagram. Which way is your arrows going? X must be less than, it must be more than a quarter. Okay. Looks like you must get marks. Alright, you will give it if you deserve it. People, it says here, without solving x, most of you go solve for x. Okay. So, determine the nature of roots. Nature of roots is dependent on what? Delta, which is b squared minus 4ac. What's your b value? Negative 4 squared minus 4. Your a value is 1 and your c value is negative 5. Which gives you 16 plus 20, which is 36. Is this a perfect square? Yes. So roots are real, rational, and unequal. How we mark this? 1 mark there. So the first 2 is 1 mark and the next one is 1. 3 marks. Okay. If you had solved the sum, of course you can't get the mark. This marking. But in your nature of the roots, I gave you that mark there accordingly. Okay. People, this is 3.2.2. First get it in standard form. So 2x squared minus 3x plus 5 is equal to 0. So delta is b squared minus 4ac. Your b value is negative 3 squared minus 4. Your a value is 2 and your c value is 5. So that gives you 9 minus 20 is 14, which is negative 31.
So is it a square root?
No square, no. Only delta is what you're working on. So the square root of a negative is, if this is less than 0, it's imaginary. So, no real solution. Or non-real roots. Non-real roots, okay. That is what I expected you to have done. No square root, no solving for. Hey, I don't know. Next. For which value of p will the roots of be real? Again, the roots are dependent on delta. Get it in standard form. So delta is b squared minus 4ac. What's your b value? Negative 6 squared minus 4. Your a value is 1 and your c value is p. So it's 36 minus 4p. So this is what delta is. 1 mark. Now, 4 equal roots. What do we know? Delta is equal to 0. Which means to say that 36 minus 4p is equal to 0. Negative 4p is equal to negative 36. P is of course equal to 9. P is equal to 9. So 1 mark there and 1 mark here. If that 0 come in from nowhere, then you get 2 out of 3. Okay. Provided you got 9 for P. People, a lady travels 180 kilometers from her home to see her. People, we spent, I don't know how many lessons on this word problems. And nobody got it right. Besides one. Okay. A lady travels 180 kilometers from her home to see us. On a return journey, she travels at night and travels 30 kilometers per hour slower. The trip takes 1 hour longer. At what speed did she travel back home? So what do we say? We say let initial speed be x. So we go into a table here. So you've got DST, speed, distance, time, to and return. the speed. You let the initial speed be x. If she's traveling home 30 kilometers slower, so it's x minus 30. The distance covered back and forth is 180. The time taken, time is distance over speed, so it's 180 over x. The return journey, distance over speed is 180 over x minus 30. To set up the equation, we now say it takes her 1 hour slower. So you must subtract the 2. So of course, which one is going to be larger? Return. Right? So it's 180 over x minus 30 minus 180 over x is equal to 1 hour. We start take the difference of the 2, should get 1 hour. What's your LCM here? LCM is x into x minus 30. So we got 180, so this must be multiplied by x. This must be multiplied by x minus 30. And this must be multiplied by the whole everything. Right, so we multiply out, we get 180x minus 180x plus 180 times 30 equals x squared minus 30x. So 0, that cancels, equals x squared minus 30x minus 180 times 30. So I can either use the quadratic formula or the calculator or roots or completing the square. Whichever you want to do. I'm going to just use the calculator, which is going to allow me to speak nicely to it. Alright, so you got 1, negative 30, and negative 180 times 30. Or you could have written it as 5,400. So it's 90 and negative 60. But it was going to be negative, not so. But remember, what's the return journey? X minus 30. So on the return, it's going to be 90 minus 30, which is 60 kilometers per hour was the return speed. Okay?
So where are the marks given?
Everywhere. Okay, so for this setup here, I gave you 1 mark. Okay? And then I gave, so for this story here, I gave you 1 mark. 2, 3, 4, 5. How many marks was it? 7 or 6? 6. There's 1, 2, 3, 4, 5, and then 6 on the answer. Whoops. What can I unmute, Mr. Russia? And there we go. Just for some of you doing this in your head, 3 marks would have came in here. Okay? Right, next question. The bonus question. A piece of paper is divided into 6 squares. Label as shown alongside. The paper is folded along the lines to form a cube. What number is opposite the face labeled 6 on the cube? So if you fold this up, this will be a side. So that is up. This will connect to that. So that's also a side. Not so. Now if I bend that, it will fall, this part here will fall on this side. So that's also a side. So 2 has to be on top. Logic. All to do with logic, okay? Otherwise, if you do applied maths at university, I think there's a formula involved. Not that I know of, okay? Right. The people who are marked must mark you. Without scanning, you can bring your paper, we'll sort you out, okay? The paper, the question paper and memo can be found in the description box below.